Hi! Today we're going to talk about the light-dependent reactions, so step 1 of photosynthesis. And I'm going to break it down so we can consider it like 4 different steps with the main players. So the first thing that has to happen is that light is going to hit the plant, and the plant is able to absorb the light because it has pigments like chlorophyll. And if you recall, so photosynthesis happens inside of a chloroplast. The chloroplast is full of these stacks of thylakoids called granum, and the pigments are found in the thylakoid membrane. So this picture that we're looking at over here, like that pigment molecule, just picture it inside of a thylakoid, inside of a chloroplast. The name of this is photosystem 2. So the name of the place where everything is stored is photosystem number 2, like that green thing. This is photosystem number 2. So sunlight is going to strike the plant, photosystem 2 is going to absorb the light, and it's going to create these high energy electrons. Here you can see a high energy electron going on its way. After the electron leaves, we need more electrons. Like the electron is going to leave photosystem number 2, we have to get new electrons from somewhere. And there are enzymes in the thylakoid whose job it is to split apart water into hydrogen ions and oxygen. And if you recall, oxygen has 2 lone pairs of electron. It's really negative. So we're able to take the electrons from the oxygen molecule and use those to be able to replace it. So when more sunlight hits, more electrons can get energized. And then what happens to the oxygen? It eventually gets released into the atmosphere and we breathe it in. So thank you, plants, for doing that for us. Now let's follow the electron and see where it goes next. It's going to go to a place called the electron transport chain. So we can see the electron is moving through that purple protein called the electron transport chain, and when it moves through there, we use the energy from the electron to pump hydrogen ions into the thylakoid. This is a low concentration of hydrogen ions, and this is a high concentration. Going low to high is active transport, so it requires energy, and we're able to use the energy from the electrons to pump hydrogen ions in. Why are we pumping hydrogen ions in? Because that will be important in step 4. Now the electron has used up all of its energy, so it needs to go to another photosystem. This time it goes to photosystem 1, but this kind of the same thing happens where more light strikes it and it energizes the electron. This time it's picked up by an electron carrier. So the low energy form is called NADP+, and then when it picks up its electrons, it gets a name change to NADPH. So the whole point of this phase was to have an electron carrier, NADPH, pick up the electrons, and then they're going to be used in the light-independent reactions. And then finally, let's get back to why we had to pump the hydrogen ions in. The reason is we're going to use that gradient to be able to make ATP. So this is a protein called ATP synthase, and this is the inside of the thylakoid. So like before, here was photosystem number 2, the electron transport chain, photosystem number 1. So now we have all of these hydrogen ions inside. They want to flow out from a high to a low concentration, and when they flow out, it's able to add a phosphate to ADP and make ATP. So the whole point here was to be able to generate NADPH and ATP. Here you can see it all together, and I will recommend that you watch this video and please email me your questions. Thank you.